As countries around the world attach more importance to primary healthcare, the investment into the primary healthcare sector has increased dramatically, especially for health commodities and services. Among them, the most important is vaccines, which leads to the demanding requirements on the cold room chain capacity and the ability for storage and transportation. The first stop of all vaccines to countries are the National Central Vaccine Cold Rooms. However, the current AC cold rooms and conventional solar cold rooms are facing many challenges in deployment, operation, and maintenance, such as high operational costs, high power consumption, low robustness, and the inability to control remotely. Welcome to the HIAR Biomedical SDD Cold Room Launch event. In response to the above issues we are facing in the industry, HIAR Biomedical has innovatively developed an SDD, Solar Direct Drive Cold Room, which has been completely upgraded from the power supply system to refrigeration system and monitoring system. It is my pleasure to explore the secrets of the HIAR Biomedical Solar Direct Drive Cold Room together with you today. First of all, we would like to discuss the power supply system for the two main types of cold rooms in the market. AC drive cold room, which is powered by a 220 or 380 voltage power source, which also includes a backup diesel generator, and conventional solar cold room, consisting of a solar panel, battery bank, charging controller, and an inverter. Even though these two types of cold rooms are currently the mainstream products in the market, they also have their challenges. For example, the daily power consumption of a 20 cubic meters conventional AC drive cold room used in Nigeria can reach up to 30 kilowatt hours per square meter. If the power is supplied by a diesel generator, then the fuel consumption will be 10 liters per day, which means the cost of fuel will be at least $6 per day, $2,190 per year, and $22,000 every 10 years. To ensure normal operation at night and during rainy days while using the 20 cubic meters conventional solar cold room in Nigeria, an extra battery bank must be used to drive the cooling system, and the replacement cost of a battery in 10 years will be at least $20,000. Also, both the AC drive cold rooms and conventional solar cold rooms require grid power as a backup power supply, which is not possible in some places where the electricity supply is unstable. Another issue that is faced by this system is that key components of the cold room are often damaged due to abnormal voltage fluctuations. Also, the compressor and control system capacitors, resistors, diodes, and other electronic components can malfunction. Due to these causes, the equipment may even have some other abnormalities, such as aging or damage of components, and also equipment stoppages. To solve the above problems, HIAR Biomedical developed the Solar Direct Drive Cold Room. The refrigeration system and electronic control components are all DC driven, and solar panels drive the refrigeration system directly without an auxiliary battery. For example, by using a 20 cubic meters HIAR Biomedical SDD cold room in Nigeria, which is equipped with 6 independent refrigeration units and 2,700 watt solar panels, will operate normally under the minimum solar radiation reference period of 3.5 kilowatt hours per square meter every day. In terms of power supply, the only consumption is solar energy, so there is no energy cost associated with the HIAR Biomedical SDD cold room. Total cost for ownership is very low. The working voltage of the cold room cooling unit is 32 to 60 volts of direct current, which is relatively wide, and the fan is driven by the constant voltage of 24 volts direct current from the compressor output. It also has lightning protection and grounding devices to effectively prevent electrical components from being damaged by lightning, which ensures stable and safe operation of the cold room. Finally, the HIAR Biomedical Solar Cold Room does not use batteries and does not consume fossil energy or produce harmful gases. It is energy saving environmentally friendly, and is fully compliant and in line with the UN Sustainable Development Strategy requirements. First of all, the Haier Biomedical Solar Cold Storage Room utilizes ice thermal energy storage technology and uses solar energy to produce cold storage capacity. Even if there is not enough light during night or rainy days, the frozen ice in the water tank will slowly release its cold energy to ensure that the temperature in the cold room can be maintained at 2 to 8 degrees Celsius. Its holdover time is at least 3 days at 43 degrees Celsius and 5 days at 27 degrees Celsius. Even if there is a failure in the cold room, there will be enough time for troubleshooting. The conventional cold room is greatly affected by the power supply, and unstable power causes the temperature to fluctuate. Its handover time and power outage is less than 8 hours. If related services and vaccine transfer is not conducted in time, the vaccines are at risk of damage and spoiling. The Haier Biomedical Solar Cold Room adopts PLC technology. It can accurately display and control the refrigeration unit to make the temperature more uniform. Meanwhile, the PLC can start the cooling unit based on the solar radiation to fully use the solar energy. For example, starting only one cooling unit around 9 a.m. and then the other 3 to 4 units will start during midday, according to the requirement of the cold energy compensation. The Haier Biomedical Solar Cold Room comes with a user-friendly 10-inch LCD screen. This is convenient for real-time data reading and historical data exporting. At the same time, the temperature alarm value can be set by users. When connected to the internet, users can log in remotely from a PC or mobile device. To view the data, check the temperature, alarms, compressor operating system, all in real time, and also check historical data. The engineers can also use the error log to carry out remote diagnosis and control the system remotely. For example, the engineers are able to remotely turn on or turn off the compressor, provide remote operating diagnostics, and make any adjustments as needed. However, for a conventional cold room, users can only manually record running data on site without remote access. The Haier Biomedical SDD cold room will also be equipped with LoRa, which is a remote temperature monitoring device. LoRa is a low-powered, self-networking monitoring equipment system. This unique system can simultaneously collect temperatures, door open-close status, and power on-off status from multiple cold rooms or multiple vaccine fridges. It also supports remote monitoring and management, which is capable for monitoring the status of cold rooms at all levels. The Vaccine Stock Management System is able to monitor the status of vaccines at various vaccination sites across the country. By reviewing real-time vaccine stock status from vaccination sites at all locations and levels from around the country or region, we can monitor and provide monthly or annual inventory reports, inventory trends, and inventory stock warnings and historical consumption reports. EPI managers can make data-driven decisions. Haier Biomedical is always user-oriented, continuing to invest in independent innovation, research, and development. At present, Haier Biomedical has developed the cold rooms for vaccines, pharmaceutical needs, and blood banks. Also cold rooms with constant temperature and humidity regulation, a fruit and vegetable cold room, and other ecological products as needed. It can meet the needs of cold storage in healthcare, blood station, scientific research, animal husbandry, agriculture, biology, the chemical industry, and other related industries. At Haier Biomedical, we will continue to adhere to the IoT technology advancements and empower the life sciences of the future. Haier Biomedical, intelligent protection of life sciences.